Today I'm joined by two guests who bring both the business and the technical lenses on enterprise AI. Anand Nimkar, a partner at Deloitte Applied AI Practice, where he helps organizations in banking, insurance, airline, and healthcare design and deploy AI systems. And Julien Launay, co-founder and CEO of Adaptive ML, a startup focused on reinforcement learning and fine-tuning LLMs to make them reliable and domain-specific in enterprise environments. Thank you for joining us. Happy to have you both in this discussion.
Thank you for having us, Joe. Good to be here.
Thank you. Good to be here.
Awesome. So maybe we start with a quick, maybe deeper introduction from both of you, as I just touched on it. I know you guys have been around the industry for a long time. So Anand, can you give us a little bit on your background? And when did you join Deloitte? What's your focus there? So we have some more context for the conversation.
Yeah, so I've been at Deloitte for about 15 years now, which is, when I think about it, quite a long time to be at one place. When I first started, I was initially focused on kind of risk and security. I soon moved into distributed systems, and I did a lot of implementation in this, for large scale enterprises doing distributed systems engineering. And then about 8 to 10 years ago, I moved into AI. And initially with AI, it was more so, conversational AI. So like simple engineering on like AI factory platforms. And essentially moved into more fine tuning of models and LLMs. We actually got into LLMs like 2 years before ChatGPT, mostly because we were focused in the contact center space, which always had a business case, kind of going back 5 years. And since then, we've extended the footprint of LLM work that we're doing into multi-agent systems, and now kind of marrying the two together, large-scale distributed systems with AI agents, which is what we do. We go kind of end-to-end strategy, implementation, operate, and I've been part of many journeys with clients from idea all the way to implementation through to like running these systems.
Amazing. Thanks for joining today. And Julien, how about you and Adaptive? Maybe a few words about why you started Adaptive, what you guys are focusing on, and what's your background?
Yeah, totally. So at Adaptive, essentially, the way we like to present ourselves is that we are building a RL Ops platform for enterprise, so enabling enterprises to run reinforcement learning workflows on large language models. And kind of why are people interested in this? It's kind of two reasons that actually boil down to the same thing from a technical point of view, but like the key idea is going to be to pack more performance into a model. And you can take this in two ways, which is one way it's like cost efficiency, where now, and I think this is probably a subject we're going to touch on later, but actually the volume of tokens for every use case has grown tremendously. And so cost can become very high very quickly. So if you're able to deploy a smaller models, you're able potentially to save quite a bit. And we commonly see, enterprises having use cases with like trillions, tens of trillions of token on a yearly basis. So this might represent, millions of dollars of savings. And typically, we see that by specializing a model, you're able to get anywhere from like 50 to 90% cost saving, which is obviously very significant. The other angle to this, which is still the same idea of packing more performance into a model, is that there are use cases where you just want to push the frontier, where you just want to do things that are not possible currently. And we see this especially in the context of tool calling, of like function calling, tool use, MCPs, all of that, where models, and this is, I'm sure this is a subject we'll discuss much more today, but like models struggle a lot with like composing, complex tools, with interfacing with novel, complex enterprise tools. And this is where reinforcement learning can help and help teach models perform better. And yeah, that's really the gist of what we do in a minute.
Amazing. And there's a reason I brought you guys together. You've been working across the globe for, I guess, a couple of years. Maybe one of you can give us a little bit more color on that front, like what's the partnership is about, how you help each other.
Yeah, maybe I'll start. So, the way we kind of ran into each other was pretty random, actually. It's through a mutual friend at Hugging Face, who eventually joined Adaptive. And we always saw the potential in reinforcement learning for LLMs. Like if we look at why we're even here and talking about this stuff is because ChatGPT was tuned with reinforcement learning from human feedback. Since then the techniques have just kind of they've become way more advanced. Using AI feedback, using more execution type feedback or objective feedback. So we were looking for partners, like potential a company to partner with or collaborate with that really understood the space. And Julien and his team, they're some of the world's foremost experts in this stuff, right? Like I think Julien he worked on the Falcon project before this, and he was at Hugging Face himself. And I think what's unique about the approach with Adaptive is they're kind of not just focused on the technique of RL, but they focus kind of end to end on the RL ops lifecycle. So anything from model selection, evaluation, tuning, through to parameter efficient hosting of these models, so that you pack more performance into a single GPU. And when you kind of go end to end like that and make it simple for our clients to essentially do this stuff, because RL is quite hard to understand, to actually program, to get more performance out of. The whole mission of Adaptive, I guess, to make that easy, right? And we've seen a lot of success together. We've tried them out, initially on some small projects, eventually scaling up to very large ones, and we saw quite a bit of success using RL to give more behaviors to a single agent versus, creating a multi-agent system, and I think this is it's a bit antithetical to the common narrative, which is everything is multi-agent. We got to have multiple agents specialized in different domains to do different things. When in reality, and you look at what Anthropic is doing with Claude, what OpenAI is doing, ChatGPT, they're training these models on a lot of, varied long form tasks across domains. They're essentially packing a lot of behaviors into a single agent, right? And what Adaptive has allowed us to do is give some of our clients that ability to do that too, right? Which ends up going a long way when you start to think about use case proliferation across an enterprise. Or if you look at how an enterprise can actually generate durability in this AI wave, essentially, build data assets and AI assets that actually increase the enterprise value. I think this is the way, right? And this is why we've partnered together and worked together pretty much on every major engagement since we started working together. I think 18 months ago is when we started.
Yeah, totally, yeah. And I think I want to add like another angle to this, which is, and I think Lior might be particularly, interesting for like adventures for the startup world, which is that I think as a startup, we made a very early decision to target enterprises, which obviously is difficult when you are like, much smaller. There is like a question of reputation. There is a question, of convincing, getting into these very large accounts. And
Definitely.
partnering with people like Deloitte obviously is really the right move. Like we have found it to be amazing in terms of like being able, you are kind of under their umbrella of trust. You learn a lot from that. You get access to like very exciting and much more large scale use cases. So it's something that, from a more like business strategy point of view, is also really cool and really nice to see come. And nowadays we have quite a few engagements together, and like it's a very fluid and very efficient relationship in many ways. So when I think it's a great success stories in some way of this sort of approaches for startups, and I think that's like a big motivation for working with Deloitte has been that. And there's a question, by the way, in this, and this is a longer topic, but that's very difficult to build this relationship, particularly because you have to find the right people. And I think something that we were lucky, at with Deloitte and specifically with Anand, I think, is that they are quite forward-looking in terms of the technology. They really want, to really push the best and really think about what's next, because these engagements last for years, for this, like for the end customers, these are massive transformation of their business that, should be lasting for years in a field where things change every 6 months. Obviously, that requires you to be a little bit forward thinking. Otherwise, in 1 year or in 2 years, you're gonna realize you're holding the bag, that you just like got sold something that's already outdated. And I think this is something we really enjoy in that relationship. Is that the team at Deloitte are very technical and very forward looking on the tech and really open to all of this new idea around reinforcement learning, agentic behavior reasoning, all of that.
That's awesome. And I look forward to touch on some of the use cases you guys built together. But maybe before we dive into this, I want to ask maybe Anand, you've got like a first row seat into what happened in the past 2-3 years with the enterprise AI market and how it evolved. I'm curious, like, how would you frame like the market status right now? Are we still in kind of pilot and POC mode, or you're seeing companies committing to production systems already, and what's the trajectory looking like?
Yeah. So I think you're right that the past few years have been focused on POCs. We have been fortunate to work with some enterprises that were trying to move faster. Even in 2022, we were getting LLM-based use cases into production. But the vast majority were, I think, hitting a gap with regard to one, it's capability and understanding of the space, but two, I think it was like reliability and risk with regard to solutions, right? So it's very easy to POC something, but very hard to make sure it works every time, or at least to a degree that for a business process would reduce the risk exposure for the enterprise, right?
Was there like a notion of low hanging fruits across the board? Like, I don't know, maybe operating a chatbot, just like customer service, which was maybe easier than operating backend systems or anything like that?
Yeah, exactly. So like RAG based systems, employee facing RAG was like the fast, like it was like we saw that everywhere because it was easy to do. There was a lot of examples out there. And if the answers were wrong, we still had a human in the loop. I think so from a risk perspective, we saw that. But of course, like the higher value business cases were for end-to-end automation, right? So they were identified. And typically the barriers to entry for enterprise were, integrations, so like essentially having the right data available and accessible to these systems, whether from a regulatory or compliance perspective, making that data available was difficult, or, their backend systems were legacy and not ready for the additional load, or they weren't built for service-oriented architectures, right? So that's what we saw. Recently, though, we've seen enterprises kind of address this gap and start to put a lot of money behind specific initiatives, usually focused on like high value, high volume use cases right now. And there's a kind of a separate track focused on citizen developer and enablement, right? So we see kind of enterprises investing centrally in building agentic platforms and making them readily usable by their IT teams. That's kind of if we're going to invest on a project by project basis, this is what we're going to use. And then separately through Copilot or Google Agent Space or, other tools out there, building citizen developer enablement just to have more kind of bottom up use cases, bubble up. So, and I think, so enterprises understand the value of AI, and from a board level down, they've been given targets. Certain executives have targets with regard to automation. Like they see it as, there's no avoiding this topic now, and so they're trying to figure out which use cases, which processes, and slowly go to the core of the operation, starting with things like contact center or things that are on the peripheral edges of that operation.
Awesome. Super interesting. This show is about like talking on the real use cases you guys have built and dig deeper into, some of the architectures and tools you've used and maybe some pitfalls along the way that we should be aware of. I'd love for you to choose one or two examples we can talk about and dive in something, maybe a project you're proud of and like a customer was super interesting, and we can talk about.
Yeah, I think one that's interesting and that relates a big trend that we see right now, was there's a lot to say is on the customer support side with an airline where essentially, when we like, this is a use case that we are working on together right now, and I think the whole like kind of the whole story is very illustrative of what we see in the industry. Where first, kind of like the starting motion for it was that when we started chatting with them, obviously they had been using. So this is the goal is to handle customer support, very broad goal. This is obviously something that pretty much any enterprise on earth right now is pursuing. I would say it's very illustrative. It's a little bit boring to an extent, but actually, what I think what makes it exciting is that they looked at what they had done previously, and they were like, well, essentially, the way we have approached Gen AI so far has been kind of as a copilot. So have Gen AI along in the contact center with the human agents and all of that. And what they realize, is that they are spending, they are not saving any money by doing this, and they are not improving customer support in any way. All that they end up doing is spending more money on Gen AI licenses, which doesn't make any sense. And this is where I think it gets exciting, which is that they started reframing it into how do we actually make this fully automated? Like, how do we make the model able to do everything essentially? Because the problem is that a lot of AI deployment, and I think this is a symptom in the industry, a lot of AI deployment that don't work fail essentially sometimes because of a lack of ambition almost, where well, if the model is only going to act as a copilot, there is only so much it can do and so much it can unlock. Whereas when you start thinking about the model also being able to take action, so being like a true agent, and I think this is very true to the definition of agentic systems. When you start thinking about this, well, now, the potential savings from a business perspective and the potential impact that you can have are tremendous because now, you have a system that is going to do everything that your employees or that your contractors can do. And that's obviously like very exciting. It does come with a massive challenge, which is that this is very complex. And customer support, especially in an airline, requires interfacing with very complex systems. So, flight rebooking, regulatory system, issuing compensation, tracking lost luggage, all of this. Like it's very, very complex, actually. If you think about when, one of your flight is canceled, the set of action that needs to be taken to get you back on the happy path is actually quite complex. And there can be a lot of like failure points in this, where like, oh, your luggage maybe is stuck, at an intermediary destination, or maybe, it wasn't like there's so many things that can go in one way or the other.
Julian,
And
when,
this
when
is
was
what
this project? So sorry for jumping in, but for context, when was this project taking place? Because there was a
it's
big like shifts in both the innovation and customer support by itself, and also
yeah.
the AI capabilities. So I'm curious when, like, what time frame you guys worked on this.
This is a project from this year. Like we started, discussions on this early this year, and we started all of the implementation over the summer. It's a very very fresh project in many ways. And I think where is it gets really exciting is like the tool use component, where now you have to teach your model to use all of these tools, and this is where we see a lot of failure from the current frontier models. And back to what I was telling you before between cost efficiency or pushing the frontier, here we are really in the pushing the frontier scenario, where if you use Claude out of the box or Open or GPT out of the box, they are really good at the tools that they know, like code execution, web search, that sort of stuff, but they struggle a lot to combine tools that they don't know. So when you expose all of these tools that I mentioned before, flight rebooking, all of that through MCPs, when you expose them, the model get lost. And what is really key is to teach them, during reasoning, to kind of combine all of these tools together to do, okay, so now I will check, regulatory information. This is what this passenger is entitled to. Now, based on that, I can process the receipt, issue them a compensation. Or now, I need to rebook them to this, blah, blah, blah. Like there is this whole like sequencing of events. And this is where reinforcement learning is very interesting because we can build kind of virtual sandboxes in which a model, will have to complete these tasks. And then we can train end to end for the model to learn to reason, to plan, how to use this tool and how to execute them. And I think this is the reason I mentioned this project is because this is a pattern that we see everywhere of like that switch to much more agentic systems with like ability to take real world action. And this is where there is a current massive gap in capabilities from off the shelf models and where specialization with reinforcement learning is extraordinarily powerful in enabling this to be the case. And I don't know, I'm sure you have some perspective to add on this as well.
Yeah, let me maybe. So this is a project that we're working on together right now. the space of aviation is quite interesting. So if you operate in multiple countries, there's regulations as you go across different continents. Specific countries, there are regulations that apply. So, for example, if you have a journey and something happens, like your bag gets lost on the journey, right? You're entitled to compensation for your lost bag, right? Or your flight's delayed. Depending on where you are, a different regulatory framework may apply. Now, we didn't actually end up going down this path, but just to give you an idea of one of the use cases we started scoping out, and how reinforcement learning kind of made this even possible, was we wanted to essentially track regulatory changes across multiple jurisdictions globally. And whenever a regulation changed, we would generate rules from that regulation or changes to rules that exist already, and then have those rules go and upload into a rules engine, right? Now, if you think about like that problem statement is actually applicable across industries. And if you weren't looking at regulations, let's say we're looking at regulations plus corporate policies on things, or kind of a vast set of unstructured data, turning that and changes to that into some structured set of rules that execute deterministically. That's a huge problem for a company, right? Typically, they have to track these things. It goes through lawyers. It goes through operations teams. It comes out as workflow diagrams. Eventually, a developer goes and configures it, and that whole cycle can take a long time. And now, if you're in an environment where the rules change every week, what size of operation would you need to have to manually address that, right? It's pretty significant. With AI, relatively easy to do. However, if we didn't have reinforcement learning, I don't think this would be possible, even with the current frontier models. It wouldn't be reliable enough for us to actually build something like this. But we had started scoping this thing out back in the summer. And with reinforcement fine-tuning, with a number of techniques around synthetic data generation, we thought about an example of let's take existing regulations and then let's simulate changes to them. And because we know what type of change we're making, we know what the answer should be in the rules engine eventually. Let's then have the model take that change and generate the changes to the actual rules engine as code and verify whether it got the change correct, right? That's a type of kind of objective, verifiable reward, right? That we can use with reinforcement learning. And it turns out with an SLM, even a smaller language model, you can achieve very high performance just on a task like that, right? Where if I were to use even the new Sonnet 4.5, which just came out yesterday, I highly doubt it would even come close to the level of performance we can extract from just a very simple reinforcement fine-tuning process around this. And there's countless examples like this where I'm starting to see that once you understand reinforcement learning in the context of LLMs, you effectively have superpowers. Essentially, you're able to achieve the promise of what AI automation can do for your enterprise faster or cheaper. And I think the fundamental problem with the reinforcement fine-tuning is just complexity. You need to have a pretty significant team of experts who understand the space to really crack into it. There's a bunch of libraries, but let's say you were to use open source libraries, you still have to figure out GPU training and inference and cluster management, and you still have to figure out model selection and evaluation, and you still got to figure out the synthetic data part. It becomes a huge problem to tackle with it. And most enterprises they don't have the capability for this. But this is kind of where we start to leverage the adaptive platform to help with stuff like that. But this it just shows you that you can essentially start to be more ambitious with use cases. And I think Julien said something earlier, which is people are not being ambitious enough. Is kind of what I read from what he was saying. Because we can actually be quite ambitious. I haven't heard an idea yet from any client I've talked to, and I speak to many clients per week across industries, across continents. I haven't heard of an idea yet that's not doable, which is actually kind of crazy. Which means I don't think we're pushing ourselves hard enough.
So where are you guys in the journey of automating 100% of the customer queries in that customer service agent?
So in that So we're still in the middle of implementation with this customer. We're planning to go live at some point in 2026.
But I mean, do you
Yeah.
think it could actually solve 100% of the use cases like
Yes.
rebooking and luggage? I have a little bit of
Yeah.
experience with the back end of airline industry. Most of the systems there are pretty
Yeah.
dated and siloed. So curious if this was any challenge kind of connecting the dots, making
Yeah.
those
We're
systems.
targeting 100% of inbound. Okay. And the only scenarios where we escalate to a human are those where there's like a fraud risk that we detect through a fraud system, right? So to me, that's effectively like the majority of interactions with like a small set of edge cases around that. That's how when we approach new projects together, we're, in the past, that's like our clients would build business cases of like 10% automation, 25% automation of inbound interactions. We're looking usually at 80 to 100% nowadays.
Yeah,
And the
that's
only thing that's limiting us is integrations, like essentially the availability of integrations downstream, because sometimes companies, they work on different timelines for making those integrations available and ready.
Sorry, what are the kind of the key challenges in that project? I imagine like working in airline scale, a lot of queries. Maybe that's one. So scaling costs maybe was one, or was there anything with regards to kind of the tool orchestration? How do you do the function
Yeah.
calling and the policy
I
engine
I
behind the scenes?
I think the biggest challenge in this sort of use cases is actually like the complexity of the environments. I mean, you hinted at it, but like a lot of these systems are like legacy systems that are like extremely old, that are like not necessarily easy to interface with. So actually, we find that most of the difficulties in essentially building the connection to this is essentially like scoping. How do we connect this? How do we, you know, put them into kind of a box that the model can interact with. We find like it's actually it's the hardest part of all of this. There are ways to approach this to systematize it. I think this is where for instance, having someone like Deloitte is really good because Deloitte is really like the teams at Deloitte are amazing at like taking a hold of like what's the current situation, where do we want to go, how and planning, how do we go from point A to point B? Like I think it's even before large language model, it's essentially all that they do, when they like sell transformation, digital transformation, implementing complex systems, that sort of stuff. So it's really like having like a partner that can break down that because it's very boring to an extent, but the complexity of this is real world complexity. It's not like there is no magical tech solution that will enable you, to write this connector. Yeah, I mean, some of this is a bit faster because you can use, you can vibe code it a bit with a cloud code or whatever. Yes, to an extent, that helps a little bit, the teams to move faster in building these systems. But the reality at the end of the day is that you have to have like a very systematic and thorough approach of like, okay, this is the inventory of what we are going to need. This is how we are going to need it and coordinate all of the parties to make sure this is gonna work well. That's the main complexity of this project. Honestly, is like going from connecting the legacy system to the models. Where I think the models are quite exciting actually is that once you have done that connection, well, now you mentioned before that the systems are isolated, which is very true. But once you have done that connection, they are not isolated anymore because now you have a unified interface to the system, which is a large language model that can like take like interface with the system in a very fluent way, combine them, and all of that. And that is a massive unlock. Like that's a huge unlock in terms of what's possible, not only for like customer support, but even like internally, for stuff potentially for internal teams and all of this. It's also I think a potential like bigger like something we are looking at for the future. So yeah, so really like a- it's a big difficulty to like overcome like in terms of bringing in these systems to something like to a standard where they can interface with large language model. But then once it's done, there are tremendous benefits in terms of kind of removing the silos and enabling you to do much more.
Yeah. And I can give you a concrete example as well around like challenges. Well, I'll use a different client in this context. So right now, we're doing some work with like a large US health insurer. And as part of this, we're building agents that, just to give you an idea of what they're doing, and by the way, I'm actually here in the US right now. We're going live this week with the system, but essentially, yeah, on a call, essentially imagine a call like so they get almost 100 million calls a year, So they're like a massive call center operation. And on a call, we're building kind of streaming deep research. So if you can imagine proactively agents that are listening to the call, and if the customer asks something or the employee says something, it may warrant a research activity, a follow up, for the employee on the phone. And so asynchronously, these agents will kick off a research task, and then they'll go and interface with like 100 different APIs and thousands of knowledge documents.
Sorry, Anand, this is more like a co-pilot kind of use case rather than full automation or replacement.
Yeah, exactly. It's an example of a co-pilot use case. But so in the first phase, we're just doing reads on this data. But in the second phase, we're going to start doing writes. So essentially workflow automations that trigger asynchronously on the call. So eventually that is automation, but it's still assistive, right? But more like a Tesla FSD type situation for a call center agent. Now, what's challenging in this type of enterprise environment, I mentioned 100 APIs, and I mentioned the ability to read and write data to them, right? What's challenging is in a situation like this, let's say you're interfacing with these 100 systems. Typically, an employee is working in like some front-end UI. Let's say in this case, it's Salesforce. Now, the organization has built, roles-based access in Salesforce. Typically, the roles are like more fine-grained in Salesforce than they are on the downstream APIs. In fact, in many organizations, because some of those APIs are legacy, there is no roles-based access for that data. And so now you have AI agents that are operating on behalf of an employee who can maybe borrow the roles and permissions of that employee, but when they interface the data downstream, there is no mapping available. Beyond that, there are certain contexts where an AI agent is not operating on behalf of a single individual, but it could be operating on behalf of a group or maybe on behalf of an executive, right? In which case, it's very difficult to map the permissions that are allowed for that agent to some downstream systems, right? So a lot of enterprises are starting to hit this hurdle, which is like, we want proliferation of AI across our enterprise, whether it's single agent or multi-agents, based on our conversation earlier. But we need to figure out how we protect our data, because there are certain usage patterns that are permitted, and there's other usage patterns which are not, and we don't know the full scope of them. And we have no way to actually bootstrap our downstream APIs to actually have a role-based permission model that actually makes sense. Because everyone understands OAuth, everyone understands scopes and how to do it, but how do you actually make the individual business decisions across hundreds or even potentially thousands of systems so that you can, get ready to actually proliferate AI, right? These are just examples of some problems we're facing. Yeah.
The issues of security in RBIC came up a lot in the past couple of months, and a lot in the startup ecosystem, as you can imagine. But I would guess there's also another aspect to it which is not related to security, which is more on kind of performance side. And you mentioned like huge scale over there. How do you make this work kind of live with the agent on a call with a customer, and you've got like potential latency or wrong answers and hallucination? I assume this was like a big battle solving that front.
Yeah. Essentially, we adopt streaming-based architectures. And earlier in my intro, I mentioned kind of now I get to do distributed systems and AI. A lot of my work is distributed systems. Essentially getting these AI agents to operate with low latency, potentially on streaming data, and still be very performant or reliable at scale, right? In a way that is cost effective for the enterprise. This is like a lot of the problems that I address now are, I'm going to say 50% distributed systems, 50% RL and AI problems, right? Because we essentially need to introduce new capabilities and a new stack typically when we enter an enterprise to actually even enable this. And that requires a whole host of things, including security reviews, networking, the DevOps, the cloud, all these kind of components, even like a FinOps and projections and estimates on cost, right? Like all this needs to happen before we can even start building AI on these systems, right? So it's a big endeavor typically.
It sounds like it's also a use case where caching could be like a big part. I assume most of the questions would come up very often. And Julian, I don't know if you have like point of view on like
Yeah.
how you guys
We
built that.
we do a lot in that space. Like the goal, I think the goal for a lot of this optimization is to be are for them to be transparent. Because when you run system at this scale and like systems that are this complex, I think if you have to think of every edge case and of like, oh, I have to explicitly cache this and that, like it becomes quickly like a bit of a like not really tractable essentially. Like you will just spend your life hunting, for constantly trying to find, what like whatever you need to cache or whatever not. So for this, we do a lot of like automated logic. In terms of serving, like actually, I think this is one thing that's really interesting actually that I found is that you can actually serve models at very, very large scale quite efficiently, especially, if they are on the smaller size, on like in the range of like 5, 10 billion active parameter, if it's an MOE, you can serve a tremendous amount of requests of query per second, with few GPU resources. And I think then, by having like a properly, proper inference stack that's properly tuned, with like speculative decoding to accelerate it, with like stateful caching, to have sticky requests to not recompute every time, all of your context from like discussions and all of this, like you can get a lot, like essentially you can get very, 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 very large throughput and low latency in production. So I think it's actually like on this, the biggest difficulty, I think, in terms of scale and resources, typically is more procuring the GPU resources, because hyperscalers can be quite difficult to work with in terms of like, they are aware that the customers typically have a lot of like data gravity with them, so they are aware, that they have a position of power, and that they don't have to make a lot of effort to break down on prices. That's actually, I think, the biggest difficulty. Because from a technical point of view, once you have a stack that's like really robust on all of these aspects, and that's very like set it and forget it, uh, you have all of these benefits, and it works really well. So yeah, that's typically what we see honestly on most of these use cases, and we saw use cases that have like tremendous, volumes of tokens on a yearly basis.
Yeah, and like
Yeah.
I think like fundamentally we try to shy away from these techniques of like caching, semantic search, on questions because I think fundamentally they're just all hacks. The faster we can get a model to respond, um, the better. And I think like there are other techniques that, like for example, being able to predict where the conversation is going to go, so you can preemptively answer a question, before it's even asked. And if that question is the same, then you can just serve up an answer. Like these are things that we've already worked on together that, with RL we can actually do versus, any other technique you couldn't really do it. So this is how we kind of get around some of the latency challenges is being able to like, almost be a precog to the conversation, like really understand where it's going to go and then preemptively do the expensive queries ahead of time.
Was there I assume those project takes time from weeks to months to get to like full production deployment. Was there any like horror story or something worth mentioning of like something breaks even before production, but some technical challenges you had to solve either because the infrastructure or the tech stack wasn't right? A lot
Yeah.
of these stuff are
We
exploratory.
we haven't had anything too bad. I think the worst we had was we had a demo where the RAG was not turned on. So essentially, when the model will trigger the retrieval, and it's essentially the model chooses when to trigger it. So the model make a function call and get something back. That part wasn't turned on, so the model was just getting nothing back. And so then the model was answering was kind of improvising, was like, well, then I will answer, based on my knowledge. And obviously, some of this was problematic, where like the model was just like answering quite badly, which was like, so it was an interesting one. And it was when we had like a bit of a moment of like, oh, what's going on? This is really not good. And like, is there something like, I don't know, like, did something go wrong? Did we not evaluate the model properly or whatever? And then, we're looking at the logs and we're like, well, actually, there is no context. Like, there is no, some model is not getting provided in document. I think that was a fun one that was like, quite scary, especially this was a customer that I think was very cautious about GenAI. And rightly so, actually. I think like I really don't put the blame on them for this. I think, they are in the education, like they are net techs, they work in education, and they want like they worked with us on getting a model that's like more educative with kids, because actually, if you look like ChatGPT or Gemini or whichever you want, they are really good at doing your homework. But that's actually a problem because like they shouldn't be doing that. Like they should be helping you doing the homework, but they shouldn't be flat out doing it. And actually, they did studies, with like psychologists, teachers, and all of that, and like kids interacting with models that like just do their homework have like fundamentally worse educational outcomes. Like it's actually degrades their educational outcomes quite significantly. And that's a huge issue. So, you know, in this, you could treat this as Gen AI slop for education. It's never gonna go anywhere. But actually they took the bet that, well, what if we were able to build a model that sidetracks this, that actually is educative, that like behaves more like a teacher would. And I think this was really interesting because they were not, big believers in Gen AI originally. In fact, they were, I think, even a bit scared about it from having seen, this like degradation in educational outcomes, like how bad it could be essentially. And obviously, when that mishap happened, that was like, we're like, oh no, it was like quite bad. But in the end, it worked out really well. And I think this was a really fun actually project because we got to work with people that are very passionate about education, and we got to find ways to like distill their expertise into models, which is also something where reinforcement learning really shines in terms of like taking a few, samples from humans, like a few like very high value. We use critics and rewrites where like the experts, like will critique like a sample from a model in natural language and say what's wrong, what should be improved. We use that and we use rubrics. It was really cool to be able to like work with domain experts on like distilling their expertise into a model and having them not feel like, like, oh, this is GenAI is like a black box, whatever, but having them feel like they have, a contribution to the process, and like everything that they say and that they do clearly like steers the behavior of the model. I think that was very rewarding on both sides, and ended up going really well. So yeah.
Interesting.
Yeah,
Can you touch on the business side of it and how like the customer is measuring ROI there? What was like how do you imagine the outcome of such a project and measure you guys?
yeah. So from a business perspective, and actually many of these projects are starting to do this. So we try to capture, um, initially we try to capture the goals of the solution. We build some high level KPIs, but a lot of the evaluation of these systems and their success is typically done with a panel of human experts. Sometimes a lot of them. Initially, they are like annotating outputs of the system in different contexts, different scenarios. And from those annotations, we try to extract and build AI judges, like LLM as a judge. And those LLM as a judge scores start to, when you start clustering them into common categories, kind of creates a rubric for the system. And we need to just ensure that the LLM as a judge is kind of scoring in a very similar way to the humans. And if they're close, we call this alignment. If they're close, then typically we just use that. And the reason for this is that's going to give you like the subjective evaluation in let's say a customer service context or in other business processes. You can essentially create more objective KPIs as well. So, for example, in customer service, you can measure escalation rate to a human, or you can measure CSAT with surveys, or things like that. But there's a lot of nuances in behavior that we need to capture through this more subjective approach. And what we find is that humans are also not really consistent in how they evaluate an output. So we need to actually capture the biases of everyone, kind of average over them, the biases of the human experts. And then just make sure that our subjective evaluation systems are kind of matching that, right? Because then we can evaluate whether we have a bit of alignment of this model. And we did the same thing in the context of this EdTech company, in that eventually we started to create judges that were aligned to things like logical consistency. So essentially consistency of the conversation. It wasn't taking you into random pathways. the actual accuracy of the solution relative to content sheets that we retrieved if there was a RAG context. RAG was more subjectively used by the model. It wasn't always used. It's only when needed, it would go and pull some content sheets that were relevant to the situation. But still, you want to make sure it's accurate. So for example, if a student is uploading a photo of their homework, the model has never seen it. We don't have it in any of our content. The model should still answer accurately, and rely on expert systems where possible. So for example, in a mathematics situation, use Wolfram. In a non-mathematics situation, use subjective content sheets to try to ground the solution into similar types of tutoring advice, right? And then there were a bunch of other kind of categories around judges that, there was this was a French Canadian client as well. So how good was the French Canadian? How accurate was that? Like a lot of judges on pedagogical strategy, which is like the tutoring strategy. So, we had child psychology experts that would evaluate this, would create strategies depending on context. It's based on 50 years of research into, how students learn, right? We have to extract that, create, dozens of pedagogical strategies that apply in different contexts, and then evaluate adherence to the strategies given the context, right? So there's stuff like that can be extracted. These are evaluations that are built together through our product management teams working with the client, and then doing that whole annotation process and creating AI judges that we can use to do reinforcement, fine tuning. Because if you think about RL, a lot of the RL work we do, when you tune RL, you need a lot of data. And so we actually need to scale up the conversation synthetically that a model is having with potentially with a mock student model. They kind of synthetically self-play and increasing to tens of millions of interactions. And we need AI judges to actually evaluate those interactions so that there is a signal for the model, to essentially improve on all of these different areas, right? So that's typically how we do evaluation.
I would love to double click on that mock student example and how you guys build it and how it helps with the fine tuning. But just a question before that, the reason you had to rebuild something like this and couldn't use GPT or Google Gemini was because there was specific pieces of the education or the context that wasn't available online that the large model could train on.
Don't even think so entirely. I think part of the difficulty was the steerability of this model is obviously you can prompt them, but at some point when the behavior that you describe is the sum total of experience of a teacher or of an expert in the domain, I mean, yeah, you can write a prompt that's literally dozens and dozens of pages, but the models really struggle to follow that and to turn that into something that's actionable. They actually tried. I mean, they actually tried a lot, with Gemini initially to get Gemini to behave in the right way, but they couldn't. Essentially, it was it's kind of at some point, the behavior that you want out of the model is so complex and so hard to describe that it's gonna be a prompt is not gonna be enough, and that's where that's where that switch to okay, we are gonna use that to drive a reinforcement learning system, to have AI judge review AI judge reviews the output based on different on different aspects that Anand was mentioning and all of that. That's where it makes a lot of sense, because then that models get tuned deeply into the model, and the model starts acting more instinctively like that, even when not being prompted. And I think this is a pattern that we see a lot, where when behavior gets rich and complex, that's where prompt tuning essentially fails.
I think the theme here is making sure the model is adapted to the specific context of the client, right? So in this case, they wanted a tutor that was hyper-local to the Quebec ecosystem, right? Because it was French Canadian, that adhered to the Ministry of Quebec, the Ministry of Education in Quebec in terms of curriculum, that understood the breadth and depth of the content available under that what that EdTech had, and that also accurately executed the pedagogical strategy that this company had spent decades trying to, or the researchers at this company spent decades, on essentially. So that's hyper local. It's hyper adapted to this enterprise, where you can't really prompt your way to success there, right? Like you can't, even with the best models out there, even like if you look at ChatGPT and they have like a study and learn mode. Now Google has it. Like they're all releasing these things. Those are not going to, those are trained for a different set of requirements. Like they're trained for a broad set of tasks, but they're not going to be hyper adapted to this client, right? And I think that's the theme with enterprise adaptation with RL is like in a specific context, if you actually modify the model weights, you're going to have better performance, often for cheaper because you can use a smaller base model and host it yourself on GPUs, which you end up saving quite a bit of money relative to like a commercial LLM. Versus like prompting on a commercial LLM means, if you really wanted to adapt and be accurate, you got to use a bigger one. It's more expensive. It's slower.
Do you
Harder
think the
to use.
future of enterprise use cases would move into smaller models and more open source models rather than using the large model labs?
Yeah, like it's either we get super intelligence, we get AGI, and we don't have to worry about this anymore, or it's like enterprises should use their data and build smaller language models. The benefit of that is you get to own the model, becomes your IP. Over time, as you add more behaviors and trajectories into it through RL and other mechanisms, those behaviors and trajectories, that becomes like a rich data asset as well. So even if like the base models improve, you can replay those on the new base model, right? And so like it's not even about the model anymore. You kind of decouple from models. You have so much data that you can essentially, you built the muscle around tuning and all that. And then fundamentally, like, organizations, like I've had clients depending on frontier models, and then every 6 months they change and get deprecated. So they have to like go through a migration process actively around every application they build, even production apps. And there are regressions, even if the model capabilities improve, there are significant regressions they have to address, right? Every time. Like it's super disruptive to depend on these commercial LLMs.
You threw it out, so I'll ask in our last couple of minutes. When do you guys think AGI would arrive? Without getting into the definition of what exactly AGI is.
Yeah, I mean, I think actually, like, I have a contrarian take on this, but not in the direction that most people think. In that, um, obviously, it's very hard to define what it is, and I think I think we are already in it essentially. I think when we will look back at history, there won't be like a date like, oh, on 20th of July 2026 is the day that AGI was born. Like, it's not how it's gonna happen. It's gonna be like a slow of like, oh, in the around the 2025 or something like this is where AGI starts, AGI, like general intelligence systems started to emerge. And I think, I think we are in it right now. I think, I think, and I think anyone that has used like Claude Code or like some of these more advanced systems where the models are really at their best, I think anyone can tell you that like these systems are, by all means, generally intelligent. Like they are truly outstanding. um, I think the question, I think it's so essentially it's now. I don't think that AGI, changes actually. I mean, long term, it's going to change a lot. I don't think it changes much in terms of like enterprise adoption of all of this. Like, I think there's still a lot of work to do to enable, these models to interface with all these tools and all of that. And I don't think it removes the need for specialization. In fact, I think even ASI doesn't entirely remove it, like super intelligence, because the thing is that specialization will always give you a better cost to performance Pareto frontier. So it means that you will always have like a better compromise. So it means you will always be able to have either further than frontier performance or more cost efficiency. And I think actually one of the things that we will see in like super intelligent system is specialization of their own, where the system can decide, oh, let me fork, that part, like let me fork on sub-agents and specialize that sub-agent on some data so that, I can have like on that very like, kind of like pointy aspect of performance for that because I really need it. And you see it even from the work of the Frontier Lab, where if you look at the models, that have achieved like IOI gold medals or all of that sort of stuff, a lot of them are not the generalist models that you get served. They are specialized models for mathematics, for reasoning, for that sort of things. Um, and so I think this is really something that's going to be like a really big component of all of this is the ability of models to specialize themselves for specific domains to be able to tackle them and to learn them most efficiently. That's really how I think about these things.
Awesome.
Yeah,
Yeah, sorry, Anand, go ahead.
yeah. I was gonna say, like I find this it's a moving target, right? What AGI is, and it's always been this moving target. What I find funny about it is, in pursuit of this label of AGI, we are like seeing our world completely transform around us, right? Where the things we are doing are very different than the things we were doing like even 2 years ago, and the type of capabilities enabled by these systems are is so much better. Like like Claude Code is quite powerful, for example, and I would say the vast majority of enterprises are underestimating the capabilities of these models. Even the frontier models without specialization, they're underestimating the capabilities and what they can do. People have been able to extract very powerful performance out of these systems, with specialization, but also just through better context engineering, to the point where it would likely completely transform that enterprise, potentially even automating 80 to 100% of the processes in that enterprise. Like we have the power now. We can do this, right? So what difference does it make if AGI is here? Like, what are you waiting for this label? Who gives a shit? The world is changing around you. Like, just use the technology as it is. And maybe we never achieve that label because we keep pushing we keep pushing the definition to something else. Like, who cares? But fundamentally, I think for me, you got to learn to adapt. And I don't think people's jobs are going away. If anything, I think we're going to produce more as individuals. Like we're going to become islands of productivity that, using the systems to kind of create new things. If we want to, right? And, there could be a significant number of people that just don't want to work as well. But I think it's going to give us that optionality and choice.
Like
So I'm more
always,
optimistic around it. Yeah.
jobs will probably change rather than completely disappear. We almost up on time, but before we wrap up, just in the last minute, I'd love to get your respective advice for either like executives or AI practitioners. If there's one thing you would want to shoot out to people who are in the midst of building, thinking about their projects.
Yeah. I think one thing is circling back to something we mentioned at the very beginning is like to be more ambitious. I think with a lot of these things, like the technology moves extremely fast, and what's ambitious today is not going to be ambitious in 6 months. So I think like there is really like kind of like being able to have that foresight. The other thing on a much more like practical basis, I think people underestimate tremendously the importance of like defining what success look like and what KPIs you want to measure and all of that. This is obviously very boring to an extent. Like it's something that's very down to earth, but it's actually really important. And this is an experience that we have had like wider than with Deloitte, because with Deloitte, we put a huge emphasis on that, on like defining, okay, like what defines success, what KPIs do you want to optimize, how do we define, all of these categories of model behavior, and we write pages and pages on this, like rubrics, that are like, pages after pages of like model behavior description, because they are really important to be able to tune that. I think more, for us directly at Adaptive, the engagements where we have seen less success are often when people are very fuzzy about what they want to get out of the model. So like, oh, it would be good if it beats GPT-5, but we don't really know, like maybe that's enough, maybe not. And then you're like, well, okay, but like if you don't know that, there is, like then there is, you're never gonna know like what success, like what it looks like or anything. And this is especially important with reinforcement learning, where if you think about reinforcement learning, it's really a matter of like, if you can measure it, you can optimize it. But like, so if you can't measure it, well, then it goes nowhere. Like you have no idea what you're going to be optimizing, and you're not going to be able to do it. So actually, I think this is a really important step, is really thinking about like defining what does success look like and what does ideal model behavior look like.
Awesome. Thank you.
Yeah. And my piece of advice would be like, for any new founder is like the technology is changing quite a bit. Model capabilities are evolving. We're at the point now where the model can build agents on its own, right? Like you can essentially build agentic systems with an agent, and then you can even do that potentially at runtime, right? Like so, your application will kind of build itself eventually, right? So I would say really just hyper focus on the business problem, really understand that problem, and spend a disproportionate amount of time in really getting to, what Julian is kind of saying as well is if you focus on the evaluations around that problem or that process you're trying to optimize, like really you need to understand the nuances of everything you're trying to achieve. Because ultimately, the role of humans in building software or building companies is going to be defining what behaviors we want out of the model and how do we evaluate that the model has actually achieved that, right? The rest in the middle is kind of, with code automation and with all the automation we're seeing, that process is going to be faster, potentially even done in parallel by multiple models, right? So like you can, as long as you understand the problem domain and what you're trying to solve, you can get there in like a million different ways in parallel, right? Like, and I see a lot of potential with that, but I do see in industry, even as we go through and implement these solutions, I do see that people are not really focused enough on understanding their own business, for example.
Amazing. Appreciate the thoughtful conversation, guys. I definitely learned a lot. Thank you for taking the time to join.
Right. Thank you very much. Have a good day. Bye.